right ventricle. So it's got to go to the right ventricle. And the ventricles we saw were much larger because they have to pump the blood out to the body. So when the ventricle contracts, it's going to be sending blood out of one of those major vessels, carrying blood out to some part of the body. Now, the right side of the heart sends blood to the lungs, so it goes to the pulmonary trunk. And again, that would split to the pulmonary arteries, although we probably didn't see that. And that would go to the lungs. The blood goes in the lungs, goes to the capillaries, picks up oxygen, releases carbon dioxide, all the stuff you expect would happen. And the blood has to then go back to the heart. So what blood vessels take it from the lungs back to the heart? Well, that, you need the chambers, but the blood vessel would be the pulmonary vein. So the lungs, the blood goes to the pulmonary veins, which then goes into the left atrium, as we saw. The atrium does the same thing on the other side now, so the left atrium is going to pump the blood to the left ventricle. The left ventricle is going to pump the blood out of the heart. What's the other major blood vessel leaving the heart? Aorta. So it's going to go to the aortic arch first because that has several possible pathways it can take. So here we've got several options. So a drop of blood in the aortic arch based on the fetal pig circulation has 4 options, 3 of which we could see. So the first would be to go to the dorsal aorta. That's going down to your abdominal organs. That's where your renal artery and vein were found, all that stuff. So I'm just going to sort of summarize that with abdominal. So that's one path off. What were the 2 branches that came off the aortic arch?
Brachioencephalic.
So the brachiocephalic.
Brain swelling.
And the left subclavian.
So I was saying that right.
Left subclavian artery. Now there's one more that we didn't see, and that is it can go to the coronary arteries, to the heart itself. So these are your 4 options. Coronary arteries go to the heart itself. The brachiocephalic trunk goes to the right arm and the head. And I'm not going to have room to draw, the carotids, jugulars, and all that stuff, just because there's not room to do all that. Left subclavian artery goes to the left arm. At this point, the blood is going to be used to supply oxygen and nutrients to these organs. Now we've got to get the used blood back to the heart so the process can be repeated. So each of these has to have a set of veins that carries the blood back towards the heart itself. So the abdominal organs, what vein is going to be carrying the blood from the abdominal organs?
Is that the renal vein?
Well, the renal vein comes specifically from the kidney, but that joins up with a large blue vessel that runs up.
Umbilical?
It's going to be
That would be
The vena cava. So either you call it the caudal, the posterior, or the inferior vena cava. So I'll do caudal because that's what's on your ID sheet. Caudal vena cava. And then where does the caudal vena cava go?
to the right atrium.
Goes in the right atrium. So we can just send that one back up here. All right, we'll do the heart. Where does the blood go after it leaves the heart muscle? You have coronary arteries. You also had coronary veins. So the coronary veins also dump back into the right atrium. And this is necessary because the heart can't absorb oxygen from blood that's inside of it. It has to get it from blood vessels, just like any other organ. So even though there's plenty of oxygen in the blood passing through the heart, it can't get it except through the coronary arteries and the capillaries that go with them. The left arm gets blood from the subclavian artery. That's going to then become the
jugular veins.
well, not yet. You've got coronary arteries to the heart, to the coronary veins, left subclavian artery to the arm, to the left subclavian vein. So again, these oftentimes, not always, but oftentimes have this left subclavian vein. The right arm and head are going to combine from the right subclavian vein and the jugular. So depending on which you're looking at. And these things are going to join together to make what blood vessel? Superior cranial anterior vena cava. So then I'll do cranial because that's what's on the ID sheet, which dumps the blood back into the right atrium. So this is the flow of blood through an adult. And the benefit of this type of system is the blood is kept separate. The oxygenated and deoxygenated blood is going to be kept separate. So where on this would you have oxygenated blood?
Everywhere after the
Lungs. So starting from the lungs, all around to the aortic arch, and then down to our different organs would be oxygenated. So down to here would be oxygenated. And then the opposite portion from the organs back to the right atrium, the right ventricle, all the way back to the lungs would be deoxygenated. So this is one of those places we have to be careful. It's fairly common for people to have been taught that arteries carry blood with oxygen and veins carry blood that doesn't have oxygen. That's why the red and blue comes into play, although deoxygenated blood is still red, it's not blue, but that's a whole separate issue. But the problem here is that the pulmonary arteries and the pulmonary veins are the opposite of that. That the pulmonary arteries are carrying deoxygenated blood, and the pulmonary veins are carrying oxygenated. And the reason for that is that the name of something as an artery or vein has to do with the direction of blood flow, not the type of blood. Specifically, an artery carries blood away from the heart. A vein carries blood towards the heart. So the foramen ovale, which is on your ID sheet, that connects the right atrium and the left atrium. And the idea here is that when blood comes into the right atrium in an adult, it has to go through the pathway to the lungs. If you're a fetus, there's no point in spending energy pumping blood to lungs that aren't going to do you any good. And so there's a hole that literally lets the blood bypass the right side of the heart and go directly to the left side.
What's the function of it again?
It lets the blood bypass the lungs in fetal circulation. Now, you may have heard of somebody who had a hole in their heart. It's a fairly common birth defect to be born with a foramen ovale that's still open. It's called a patent foramen. Foramen just means hole, but patent foramen refers to a foramen ovale that didn't close the way it was supposed to soon after birth. It's a relatively common birth defect, and nowadays it's a relatively minor issue. They go in, they just sort of suture it closed, no harm, no foul. Obviously, you don't want to be giving a newborn surgery, but if you need to, this is a relatively minor sort of defect that's fairly easy to fix. It does get here, and you don't want to waste that blood going to lungs that can't do any good, and so at the pulmonary trunk you have a second bypass, which I mentioned. We really didn't see it. Can I draw this without making a complete mess? Sort of. That's going to be your ductus arteriosus. It does the same thing, except it's taking blood from the pulmonary trunk. So any blood that's snuck into the right ventricle gets to the pulmonary trunk. Now it can bypass the lungs and go directly to the aortic arch. So it does the same thing, but it's sort of a backup mechanism to catch any blood that got through and didn't get taken up by the foramen ovale. And like the foramen ovale, also a not uncommon birth defect to have a patent ductus, where they have to go in and suture it, same sort of thing. Allow the blood to get to the mom.
The umbilical arteries.
All right, and that's going to be coming off your dorsal aorta. If you looked on your fetal pig, you saw those two pink blood vessels that ran from the spine up onto the little flap where the umbilical cord is. Those are going to be your umbilical arteries. Those go out to the placenta, where you can pick up oxygen, release waste products, pick up nutrients. You're basically parasitic, stealing stuff from your mom's bloodstream. You literally have molecules that can steal it from your mother's bloodstream. So you steal the stuff you need. The placenta is going to send blood back through the umbilical vein. And the umbilical vein will then end up joining up with the caudal vena cava inside the liver and send that blood back to the right atrium.